Let's take a look at practice quiz number 10 on statistics. Number 1 says a national random sample of 20 ACT scores from 2010 is listed below. Calculate the sample mean and standard deviation. So I'm going to pull up my calculator to type this data in. So you want to go to stat. So hit stat and then edit and then clear out list 1 so you can type your data all in that one list. So just be careful not to miss any numbers, and it might even help to like highlight them as you go to make sure you don't skip anything. So I'm going to take my own advice, and so I have 29, 26, 13, 23, 23, 25. Then I have 17, 22, 17. So let's see, 17, 22, 17. I have 19, 12, 26. So 19, 12, 26. I have 30, 30, 18. So 30, 30, 18. Then I have 14, 12, 26. So 14, 12, 26, and then 17 and 18. So I can tell I have 21 numbers in my list. Actually, I had to have 20 because I don't have anything right there for 21. So like right there, I can see I have 20 numbers. So that looks right. Then I'm going to go to Stat Calc 1 and calculate. And I see that I have a mean of, that's the X bar at the top of the page. So I went to Stat. I typed all of these into L1, and then I went to Stat. I went over at the top of the screen to Calc, and then you want option number 1. And then the mean is the first thing listed is the X bar, so that's 20.85. So I know A and B are wrong. And then the sample standard deviation, and they did say sample, mean, and standard deviation. That's the S, so think S goes with sample. So the S sub X is 5.94. So that would go with D, not C, because C has the population standard deviation of 5.79. So don't pick that one. All right, number 2 says, using the data in question 1, calculate the number of observations that are 2 or more sample standard deviations from the mean. So what you can do is take the mean, 20.85 that we just found, and add 2 standard deviations to that. And it just says that are 2 or more sample standard deviations from the mean. So we'd have to also subtract 2 of those. And we just want to see how many data points would be outside of these 2 numbers. So I'm going to clear out my screen. Let's see. And do this math. So 20.85 plus 2 times 5.94. Then I'm just going to hit second enter and try to go over here and change it to subtract 2. Let me insert a parentheses. Okay, so then I get 8.97. So when I added 2 standard deviations, I get 32.73. And when I subtract 2 standard deviations, I got 8.97. So are there any values in the data set that are outside of 32, like 32.73? So that'd have to be like 33. And this would have to be 9. So as I look through my data, I don't see a number bigger than 33, and I don't see anything less than 9, so it would be 0. None of them fall outside of that range. Okay, number 3 says, using the data in question 1, calculate the 95% confidence interval for the mean ACT score. So since we have the mean and the standard deviation, we're going to use that to calculate. So our formula is X bar, that's our mean, plus or minus, and then we have Z star times S, which is the standard deviation, over the square root of N. So let's just fill everything in. We had our mean that we found was 20.85, plus or minus, and then 95% confidence level has a Z star value of 1.96. Our standard deviation we found was 5.94, and our sample size was 20, because we had 20 ACT scores. So then let's just be careful with our calculator to calculate all that. So 5.94 divided by the square root of 20 times 1.96 gives us 2.6. So that's our margin of error. So 20.85 plus or minus 2.6. And we could say 2.603 if we want to carry it out a little ways to figure out our answer, or the best one from what we're provided. So 20.85 minus that margin of error gives us 18.246. And then 20.85, let's try that again. 20.85 plus that margin of error, so I'm gonna go grab it, would be 23.45. So I didn't get the exact number they did, so I might have rounded a little differently, but it definitely looks like D would be the best fit out of the choices provided. All right, question 4 says the data in question 1 appears to be reasonably symmetric, true or false. So what I would do for this one is just do a quick dot plot wherever you have a little bit of space on your paper. So I'm just gonna put mine like right here. And I'm gonna plot mine from 12 to 30 because I've already noticed that that is the lowest number I would possibly need and the highest number I would possibly need. And so let's go from 12, and I'm gonna go up in increments of 2 because I think that'll be easy enough. So 2, 12, 14, let's see, 16, 18, 20, 22, 24, 26, 28, 30. And then I'm just gonna plot these so I can take a look at how symmetrical the data looks. So I have 29, 26, and 13. Let's start with those. So 29, 26, and 13. Then I have 23, 23, 25. So 23, 23, 25 would be about right there. I have 17, 22, 17. So 17, 22, 17. Then I have 19, 12, 26. So 19, 12, 26. Then I have 30, 30, 18. So 30, 30, 18. And then I had 14, 12, 26. So 14, 12, 26. And then I have 17 and 18. So 17 and 18. And I know my mean was 20.85. So if I sketch the mean as like 20.85, looks like it's about right there around 21. Then I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points over here on the right. And that means I would have 10 points over here on the left. So I would definitely say that looks pretty symmetrical. So I would say reasonably symmetric is yes. So just looking at symmetry, you want to look at like, is your data evenly distributed on the left and the right and centered around the mean? So in that case, this would be symmetrical. There's an equal number of data on either side, and they go out from the mean about the same amount as well. Okay, number 5 says, the senior class president of a large university claimed that 45% of the senior class was interested in going on the senior trip. To test this claim, the senior class president conducted a survey of a random sample of 50 seniors, and 14 said that they wanted to go on the senior trip. To better understand the significance of the survey results, a simulation was devised based on the claim that 45% of the seniors wanted to go on the trip. Each of the sample size 50 simulated 100 times. Explain how the results of the simulation can be used to support or refute the senior class president's claim. So we could say, what is an appropriate estimated confidence interval to represent this sampling distribution? So we can see based on the sampling distribution, it definitely looks like the center of our data would be right around here, which does look like it's estimated to be approximately 0.45. And then it goes out about an equal amount in both directions. So if we say like 0.45 minus this lower limit of 0.28, we get about 0.17. And then 0.45 plus 0.17 would give us about 0.62, which is really close to like this end of our graph. And so that looks like a pretty decent confidence interval that we can just estimate with our, just visually like looking at their graph. So I'm going to write that out. 0.45 was our estimated mean, plus or minus 0.17 for the margin of error. Gave us 0.28 to 0.62. So a follow-up question could be to say, like, the sample of 50, like 14 said they wanted to go on the trip out of a sample of 50. So what is 14 out of 50? Because that's what they got based on their one sample. Like, would that be reasonable or not reasonable? So 14 out of 50 was 0.28. So when you look at 0.28 on your graph, it's way over here. So what we say in statistics is, since it's not something that popped up very much in the simulation, that it's not likely to have happened randomly. And so it's statistically significant that we got this sample of 0.28 from our, or we got the proportion of 0.28 from our random sample of 50. And 14 said they wanted to go. So we would say that is statistically significant because 0.28 most likely did not occur by chance alone or like randomly. Because it's way over here, and there were only 2 out of 100 times that this was simulated. So that is it for our practice quiz number 10.